Hello everyone. Let us now discuss today's LeetCode POTD. LeetCode 862, shortest subarray with sum at least k. So we are given with array of integer nums and an integer k. So we need to return the length of the shortest non-empty subarray whose sum is greater than or is equal to k. That means at least k. So we are also given with an example nums is equal to 1 and k is equal to 1. As we can see, 1 is the only sum we can get. As 1 is the only element, we return output as 1. This is the subarray and the length of the subarray is 1. And then 1 comma 2 and k is equal to 4. If we go through the array, we can't find any subarray. This is one subarray, this is one subarray, and this is another subarray. We cannot find the sum as 4. For this subarray it is 1, and for this subarray it is 2, and for this subarray it is 3. So the output here will be -1, as we doesn't have any subarray whose sum is greater than or is equal to k. So we are also given with another example 2 comma -1 comma 2 and k is equal to 3. If we see clearly, 2 and -1 will become the sum as 1, and the next element will give the sum as 3. If we consider this individually, we cannot get the sum as greater than or is equal to k. So the size of the subarray whose sum is greater than or is equal to k is 3. So we return output as 3. But if you consider the sliding window approach, the first approach will be a brute force approach, the second approach will be a sliding window approach, but this will not execute correctly in some edge cases where we are included with some negative integers too. So this is not the correct approach. The correct approach will be how we will be using the DQ. Here in the DQ, we will be storing the prefix sum, and then when we got this prefix sum, that means at every index we will be storing this prefix sum. And then, so initially the prefix sum will be 0, and we iterate through the array, and after doing some operations, I will tell you what they are. We will push the prefix sum and the I into the DQ. So listen carefully. The DQ's operation can be done removing from the front and can be removed from the back. Imagine we are given with an example 2 -1 2 -1 2 and then 4 -1. Here if we see clearly, 2 -1 2 4 -1. Here if we see clearly, and k is given as 5. 2 at the first index we got the prefix sum as 0, 2 and the index 0. At index 1 we got the prefix sum 2 -1 is 1 and the index 1, and then 1 plus 2, the prefix sum plus the current element will be 3 and the index is 2. And then for 4, 3 plus 4 is 7 and we got at the index 3, and 7 -1 is 6 and we got at index 4. The answer will be 2 is less than 5, 2 -1 1 is less than 5, 2 -1 1 plus 2 3 is less than 5, 3 plus 4 7. This is maybe this could be the size of the subarray whose sum is greater than or is equal to k, as the sum is 7, but the size is 5 here. And then if we consider the subarray again, 2 4 2 and 4 and also minus 1, 2 minus 1 will become 1, and 1 plus 4 is 5, which is equal to 5. And then here the size will be 3, and then it is also not this shortest length. If we consider again 2 and 4, here we get the sum as 5, which is greater than k, but the size is less than the previous subarray, that is 3, that is 2. So 2 is less than 3, so the minimum length we get here is 2. But how do we maintain the DQ? Here it will be front, and here the DQ will be storing the prefix sum in an increasing order. So we need to clearly observe here what we need to remove from the back and from the front. If we got an element, for example at 7 comma 3, 2 comma minus 1 comma 2 comma 4 comma minus 1. So if you see clearly, here the prefix sum is 1 and the index is 1. Here the prefix sum is 7 and the index is 3. So as we see here, 1 is the prefix sum and 7 is the current prefix sum and 1 is the prefix sum here. So if we see the difference here, it will be 6. Correct. Now it is greater than or is equal to k. But imagine if we are having a prefix sum like 8 in the back of the DQ, and we are having the prefix sum as just 7. Just imagine if we are having prefix sum as 7. Now we need to remove this element from the DQ, from the back of the DQ, because we cannot get a prefix, the difference which is greater than or is equal to k if we have the back prefix sum greater than the current prefix sum. That means, so imagine we have 6 here and at an index, at a random index. So if we remove 8 from here, we get a difference greater than or is equal to k, which will be a positive one, but which will it will be a negative one. But if we remove this and if we calculate the difference here, we get a prefix sum, the difference as well. That means we need to do one operation, that is, if the back of the DQ, if the prefix sum of the back or the last element of the DQ is greater than or is equal to current prefix sum, then we need to pop the last element. So this is the one important operation we need to do in the iteration. And then, so the second operation here is, imagine if we have 1 comma 1 as the prefix sum, 1 as the prefix sum at the index of 1, and we have 7 at the index 3, 7 as the prefix sum at the index 3. The difference will give us 6. And then if we doesn't remove this element, that means we need to use this index sum only for one time. So if we are having the prefix sum minus dq dot front dot first is greater than or is equal to k. So if it is greater than or is equal to k, we need to consider the length. That means I minus dq dot this is the index we are storing it, dq dot front dot second. Then this is the size of the subarray we are looking for. This is the minimum length. The minimum length will be minimum of this and the previous minimum length. So this is how we calculate the minimum length. And as I have told that we need to remove the first element as we are completed with considering the first element. So the algorithm here is we need to initialize a DQ which is having a pair int comma int to store the prefix sum at the first element and the index at the second element. Then we need to initialize the minimum length as int max and then iterate through the array. Then initialize our prefix sum will be initialized with 0 and increment the prefix sum with the current element. And if the prefix sum is greater than or is equal to k, then we need to consider this subarray. So the minimum length will be minimum of minimum length comma I plus 1. So we need to consider all the elements to this. If we are at I and if the prefix sum is greater than or is equal to k, we need to consider this subarray. And then while this is the second operation, if the DQ is not empty and prefix sum minus DQ dot friend dot first is greater than or is equal to k, then we need to consider this length. Minimum length is equal to minimum of minimum length comma I minus DQ dot front dot second. And as I have told you that we need to consider the element for only once, we are removing the element from the DQ. We are removing the pair from the DQ. So this is the second operation. For the first operation, if the back or the last element of the DQ is having the prefix sum, that means DQ dot back dot first is having the value greater than or equal to the current prefix sum, we need to remove that element from the back. We need to remove that element from the back and then push the current prefix sum with the index. And then now we can return if the minimum length, this is the first operation and this is the second operation, if the minimum length is equal to int max, if it doesn't have any subarray whose sum is greater than or is equal to k, then we return -1. If not, return minimum length. You can check the code or my submission in the description. Thank you.